Hello everyone. For today's session, I'm going to explain the microcontroller hardware lab program. Okay. The course code for the microcontroller lab is 18CSL48. Okay. For in this session, I'm going to explain the interfacing of stepper motor with microcontroller ARM7. Okay. And we are going to perform some operations like rotating the stepper motor in the clockwise direction and anti-clockwise direction. Okay. And this is the code. Okay, so this is the code for running the stepper motor. I'll be explaining each of the instruction, the why we are using this instruction and why we are initializing this particular value. Okay, so this I will be explaining. But before that, first let me show you the how exactly the stepper motor works. Okay, working principle. So for that I have a video for that, so let me play that. Okay, so this is the working principle of the stepper motor. Now we'll see how we can code this in the microcontroller. Okay, yeah, so this is the code. So we are coding on the ARM7 LPC2148. Okay, so this is the evaluation board that we are using. Okay, so this is the board. We are going to connect the stepper motor to this particular slot. Okay, it is a 4-pin slot, and we are going to connect the stepper motor in this particular slot. As you can see, and also you should know that the stepper motor requires more power. Okay, so that's why we should use the external power source. So this is the external power source. Okay, here we are going to connect the external power source so that the power is given to the stepper motor and it will rotate. Okay, and we are going to make use of these switches. Okay, say for example, if I press this particular switch, then the stepper motor should rotate in the clockwise direction, and if I press this particular switch, then the stepper motor should rotate in the anti-clockwise direction. Okay, so these are the operations that we are going to do using these switches. Okay, so for that we need to code code. Okay, so that's what I will explain how to code that. Okay, so one of the advantage of stepper motor is that we can use the stepper motor to produce discrete rotation. Okay, if we use the DC motor, then it will be a continuous rotation. But if you want a stepper motor, means if you want a rotation in discrete position, then we can use this stepper motor. Okay, yeah. So as I told, we are using ARM7 TDMI LPC2148 evaluation board. So in this evaluation board, so we are going to connect the stepper motor to these particular pins. That is port 1 pin number 24 to port 1 pin number 27. So as you know that there are 4 coils in the stepper motor, so we are going to connect these 4 coils to this particular pins, that is port 1 pin number 24 to port 1 pin number 27. And also as I told, we are going to use the switches. So here as I told, if I press one particular switch, then the motor should rotate in the clockwise, and if I press another switch, then it should rotate in the anti-clockwise. So for that we are going to use the switches. So these are the pins that are connected to the switches. Okay, this is from port 1 to port number 1.16 to port number 1.23. So these port pins are connected to switches. Okay, so we are going to use the S1 switch and S2 switch. So in order to say in order to turn on this particular switch, whenever we press that particular switch, it has to rotate. So in order to point this particular switch, okay, so we are initializing this particular value. Okay, so clock. So if I press this particular S1 switch, then the motor should rotate in the clockwise direction. And if I press the second switch, that is, you can see I have made the 16th bit, okay, for clockwise. Okay, this is in hexadecimal, correct? This is in hexadecimal. So this is 4 bits starting from 0 to 3. here it is 4 to 8 7, and from 8 to 11, okay, from 12 to 15, and this will be 16th bit, right? So 16th bit will be 1. Okay, so let me show that. Yeah, 16th bit will be 1. So if I press the switch 1, then this will be activated and the motor will should start rotating in the clockwise direction. So this is okay, this is how why we need to define these values. Okay, and here I'm making the 17th bit as 1 for anti-clockwise direction. So 17th pin is connected to switch 2. Yeah. So this is the IO1 pin. Okay, so the IO1 pin are used to get the status and set the status for the particular port pins. Okay, so I'm using the port 1 pin, so that's why it is mentioned as input output 1. It means that port 1 pins. So in this port 1 pins, I'm going to set the for first coil. I will activate the first coil. Okay, so whenever I this how the stepper motor should rotate, the stepper motor should rotate in a discrete rotation, right? So first I will activate the first coil. Okay, so for that I am making the 24th bit as 1. Okay, so this is in hex, so whenever we convert this into binary, so you can see that the 24th bit is 1. So after some delay, okay, once that rotation happens, so after some delay, I'm going to energize the second coil. Okay, you can see this. I made the 25th bit as 1. Then again, after some delay, I'm going to make 26th uh, pin high, so that it will rotate in the third step. This is third step. Similarly, this is fourth step. So this is how I'm going to run the stepper motor. So this is the overall code. Okay, um, I have initialized, so this is the header file that I'm going to use. Okay, lpc21 4x.h, so it may be the version 8 9 10. Okay, and here I'm going to define the switch. Okay, so for 16 pin I'm defining it as a clockwise, and for 17 pin I'm going to define it as an anti-clockwise. And this is the function for delay. Okay, whenever I call this function, so the microcontroller will be executing this instruction, so that it will not execute the next instruction, so it will be executing this instruction. You can observe some delay here. Okay, and IO1 DIR. So as I told that for the stepper motor we are going to use the pin number. Which are the pins? So I'm going to use the pins from 24 to 27. So these pins I'm going to use for the stepper motor. So I need to initialize these pins as a output pins. So for that we have a resistor called IODIR. So this IODIR is used for setting the direction of the resistor. Using this we can make certain pins as a input pins or a output pins. Since the DC motor is a DC motor is a output pin, so I am going to make these pins IO1 port pins as output pins. So for that I am going to initialize this value. So you can see that I have made 24 25 26 27 20 is uh, 24th 25 26 and 27 pins as 1. Okay, so this is in hex. When you convert this into binary, you can see this. I have made these pins, that is pin number 24 25 26 and 27 pins as high. So high indicates that, means 1 indicates that these particular pins are used as a output pins. Okay, and I have used another, that is pin select 2 equal to 0x0, so that the pin number 23 is initialized as a GPIO pin. Okay, yeah, and then I'm going to use a while loop. Okay, so this is infinite loop, means until I until I exit from the program, so these instruction will be executed. Okay, so first I'm going to check the status of pin number of clock, means whether I pressed the particular switch or not. Okay, so what happens? So IO pin 1 resistor I'm adding with clock. Okay, so what is the IO pin resistor? So IO1 pin resistor will hold the status of that particular pin, whether it is 0 or 1. So this particular value I am adding with clock. So whenever I pressed the switch 1, okay, whenever I press the switch 1, so this particular pin will go to 0. Okay, so since the microcontroller is an active low signal, so whenever I press the key, the value 0 will be sent. So 0 means high here, right? So this particular value becomes 0. Okay, so if I add all the clockwise bit to the IO1 pin, then the value will become 0. So not of 0 is 1. It means that this particular instruction is executed. Otherwise, if I press switch 2, then this particular instruction will be executed. So depending upon which switch I press, okay, so this run is initialized. So based on run, okay, if I pressed as a clockwise direction, run will be initialized as 1. So if it is initialized as 1, so first I'm going to energize the coil 1, then after some delay coil 2, after some delay coil 3, and after some delay coil 4. Again after some delay I am going to come back and I will check whether any key is pressed or not. If it is not pressed, the value of run will be 1 itself. So again it will execute this particular instructions, right? So the stepper motor will be rotating in a clockwise direction. So if the same thing, if I press switch 2, then I need to rotate in the clockwise direction. So that's why I'm energizing the coils in a reverse order. So first 27th pin, then after some delay 26th, again 25th and 24th. So this is how the we need to code for the stepper motor. Okay, so let me show you the video for interfacing the stepper motor to the microcontroller. Okay, so this is what we have used.
Now I will be explaining you how the stepper motor logic is executed using the ARM LPC 2148 evaluation board. See, all of you know that once after the program is executed or the compiled and generated hex code, okay, so you have to use the flash magic to burn the hexadecimal code for the stepper motor program using the flash magic. So this is a flash magic interface, user interface. I am selecting here the program called stepper motor. All of you know that we are using the COM4 4 and we are using 9600 baud rate. Then we are using the 12 megahertz crystal frequency. Then I go to browse. Okay, so in the browse I will want to select the stepper motor hexadecimal code which is generated, okay, using the Keel software. Once this is selected, I should burn the code by selecting start. Okay, so you people can observe here it is progressing. Okay, the green line which is showing the progressing of the burning of the hexadecimal code. Once this is done, okay, so as all of you know that in the logic we have explained, we have two switches, one switch to run the stepper motor in the clockwise direction, other one to run the stepper motor in the anti-clockwise direction. As we have told, I told in the stepper motor experiment we need a additional power supply to run the stepper motor, because whatever the USB cable that we have connected, even though it is supplying the power to this LPC 2148, it is not sufficient to drive the stepper motor. Why? Because stepper motor consumes more power. So that's the reason. Look at here, see, I am pressing the switches here. So one is for clockwise, other one is for the anti-clockwise, but the stepper motor is not rotating. The reason is we have not connected the power source here. So that power source I will going to connect now. See, I am connecting the power source and I will show. See, all of you observe here, stepper motor is rotating. See, I will make stepper motor rotate in. See, I'll press the switch here. See, after, see, you can see here it is rotating in the clockwise, and now I'll press one more switch. See, this rotates in anti-clockwise direction. You can see the switches here. See, these switches are used to rotate the stepper motor in clockwise and anti-clockwise direction. So this is how the stepper motor rotates at discrete interval of time. That means it is not a DC motor. DC motor means it continues rotately, it can rotates continuously, but in stepper motor it rotates in stepwise. Okay, so this rotates that means for between every step you will going to find some small delay. So that small delay will going to make the differences between the first rotation and the second rotation. You can see stepper motor is rotating in the clockwise and anti. See here, it is clockwise and anti-clockwise. Done. Okay, thank you.
Okay, so this is how to interface the stepper motor to the LPC2148. Okay, so so we need to run the hex file. I think if you refer my previous video, I have explained how to generate the hex file. Let me tell you once again. Okay, so how you need to generate. So first you need to compile this particular program. Okay, so first I need to add this particular program to the source group. So let me add this. So I have added this particular code. Yeah, so you can see that I have added this file to the source group. Okay, so now you can compile the code. So there are no errors. Okay, zero warnings. And again I will build a target. You can see that there is no hex file created. There is no hex file creation. So how to do that? So first you need to go to the project and go to the options. Okay, uh, yeah, this is the options. Okay, now this target, yeah, options for the target. So if you go here, you can see there is a output window here. So once you click on the output window, so you have to click this create X file. Okay, and then so this is one step. Okay, this is one mandatory thing you need to do. Okay, for generating the X file. So click on this create X file and also go to the linker tab and click use memory layout from target dialog. Okay, if you do these two steps, okay, then hex file will be created once you press compile and build a target. So once you're done, you can see that creating a hexa file. So this file you need to run. Okay, so let me show you where that particular hex file will be there. Stepper motor, yeah. So this is the file that you need to send to the microcontroller using flash machine. Okay, I hope you understood. Thank you.